Okay, well let's try this again. So let's start with 3.1 question number 4. And we have this polynomial right here. And you need to give the leading term. So you came up with the leading coefficient was 1. I think maybe it was just definitional. The term includes the coefficient and the variable to any power. So you'll have x times x times x times x. So that will give you 1x to the fourth. So that's what they're looking for there. And then when it comes to the constant term, and I'm not going to give you the final answer for this one, the constant term is the term without any x's. So inside each factor, we want to multiply the term that doesn't have any x's. So we have -3 times -2 times -1 times -4. Do note, and I think this was on the practice midterm, if there's just an x hanging out here, that would be x minus 0. And then that 0 would knock out everything, so there wouldn't even be a constant term. But that is not the case here for number 4. Okay, for number 5, we have this post office question, real question, by the way. And you figured out what the length is. The length is 130 minus the girth, or 130 minus 4x. And then when it came to the volume, you didn't get that. So volume of a box is length times width times height. You already have the length right here. The width is just your x, and the height is just your x. So you have the length, and multiply that by x squared. When it comes to finding the dimensions, how do you maximize that volume function? So once you get that volume, how do you maximize it? Well, the best way is really just to type it into a graphing calculator or a computer graphing program, and then find out where the peak of it'll be kind of a parabola shape. Just find the peak, and that'll give you both the x value and it'll give you the maximum volume. And then part C on number 4, you can just do exactly what you did, except with 108 instead of 130, and it looks like you picked up on that pattern. Okay, on number 6, this is the one that I've actually taken out of the requirements. This is the one with different regressions. And you actually did a very nice job on the first few. So I may end up giving a little bit of bonus towards the end of the course for something like that. But this really should have been more in a statistics course. I just saw that first part of the question and put it in accidentally. And then finally on number 7, I'll go ahead and give you this. You have the max number of local extrema. The few, it's not perhaps the best worded question. It means how few local extrema can any polynomial have, not every polynomial. And that would just be 0. 0 is like a straight line, or cubic, like y equals x cubed. Now anything that's even degree will have at least one extrema, but I think they were just trying to get a real general answer there. Okay, so let's move on to 3.2. We're at 3 questions here. So we'll start with number 1. And this is long division. You know, I looked at your previous responses here, and your first response was right on the money, except you had a -12, whereas you should have a +12. So maybe go back over your algebra there in the problem, because it seems like you have the process down. The other thing, just to make sure you're doing, is notice we have an x to the 4th, an x to the 3rd, an x squared. Make sure you are putting in a 0x term there, and also right here. So if there's any power of x that's not represented, put a coefficient with a 0 and add it in just as a placeholder. That will make a difference. And on the second one, And this is the same process. This one's actually easier than the other one, so I'm guessing here it was also a similar mistake. And again, make sure over here you are leaving a 0x in outside the divisor there. So you can see you have pretty close there. Check and see why that negative x isn't coming through your answer. And finally, number 4, you know what, really on this one you have the correct answer. I'm going to go ahead and show you that. Why don't you retype that in, factoring out the 3? And the reason they want that is because look at what, this is the correct answer they're looking for on the right. By looking at this, we can real quickly tell that x equals 2/3 is a 0, whereas on yours, you can tell by setting this equal to 0 and then solving for x, but it's not as evident, so this is typically considered a more finalized form. And that's getting a little picky. That's why I want to show you that, but it is important that you recognize why they're doing that. Okay, and finally you have section 3.3. Okay, it looks like you just have one question on that. So let's go straight to it. Okay, yeah, and this one also, I'm fairly sure that your answers for these are correct. The problem is you put them in decimal form instead of leaving them as a square root. And you may wonder why that matters. It does matter because this here on the right, the WebAssign correct answer, is a exact value. When you multiply it out on your calculator, this is an approximate value. So the advantage of this is that it's the exactly correct answer, whereas this is an estimate or an approximation. The advantage of your answer is that you can kind of get a sense where negative 0.87 is compared to 1.7, whereas this, it would be very hard to picture immediately where that is on a graph. But they are typically looking for these, and on the exam you'll have to put it this way anyway since you won't have a calculator. The other part you missed here was this multiplicity 0 on the root x equals 0. So I think you probably figured out, you factor out an x squared here. In other words, we could rewrite that as x minus 0 times x minus 0, which would be the root x equals 0 with multiplicity 2, because it's showing up twice. But I'll go ahead and give you, most of these I'm giving you because it looked like you were so much on the right track already. Okay, and that's it. I really hope the sound came through this time. Alright, bye.